Okay, this is section 6.1 in our grade 9 MathLinks textbook on linear relations. So the first question that we did today says question 4 is question 4. It says make a table of values showing the number of sides for each figure in relation to the number of octagons. So whenever you're given patterns, either with pictures or with numbers or whatever, and you make your table of values, typically what you would have done is you would have taken this being your x column and this being your y column. But what we're trying to get across now is that they don't have to be x and y, and in fact they can be whatever we want them to be. And typically x was always going to be your 1, 2, 3 typically. So if we think about what is going to be 1, 2, and 3 for this, if we have to have number of sides for each figure in relation to the number of octagons. So if we think about those two things that we have to put into our table of values, number of sides to number of octagons, this is going to be n, and this is going to be our number of octagons, right? So 1 octagon, 2 octagons, 3 octagons. So instead of saying x, we're going to call it n. And instead of calling it y, we're going to call it s for number of sides. Okay? So we think about 1 octagon. In this one here, it has 1, 2, 3, 4, 5, 6, 7, 8 sides. That's why it's called an octagon. So we have 8 sides. But the only thing is, when it has 2 octagons, it's no longer going to be 16 sides because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I screwed up. I'm supposed to have 14. Let's try that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There we go. It's a little hard because I have the shadow of my LCD projector blocking my hand, but there's 14 sides. And if we do this one, we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And of course, for 4, if we wanted to measure it, we could. But if we look here, it's going up by 6, and here it's going up by 6. So I'm probably pretty sure, since this is a linear relationship, that 26 is the number of sides my next one would have. So my table of values would look like this. And the next part says, for C, write an equation to model the number of sides of each shape. So what we're looking for is the relationship between the number of octagons and how many sides there are. And just like in grade 7 and grade 8, if you look for the difference in the y column divided by the difference in the x column, or in this case the difference in the s column divided by the difference in the n column, same thing, that will tell you, that will tell you the coefficient of your equation, So 6 divided by 1 is 6. So therefore, 6 is your coefficient. And just like in our show you know, take any ordered pair. In this case, I'm going to take the 1 and the 8 and simplify it. So the 1 and the 8. And when I simplify it, I end up with this 6 equals 8. And of course, that's not true. But if I add 2, I find the constants that's required to balance both sides. And now I have my equation for the number of octagons in relation to the number of sides. Take the number of octagons, multiply it by 6, and add 2, and you'll get the number of sides. So once we have that, what we can do then is for questions D and for questions E, I'm going to write 6n plus 2 equals s, is we can take our equation, and it says how many sides would a shape made up of 17 octagons have? So since n represents the number of octagons and s represents the number of sides, 17 octagons would be my n value. So I'm going to substitute 17 for my n, because that's the number of octagons. And I'm going to simplify using BEDMAS. And I would find that 104 is equal to s. And therefore, how many sides would a shape made up of 17 octagons have? Therefore, it would have 104 sides. And question E says how many octagons are needed to make a figure with 722 sides? This time, the only difference is instead of knowing the number of octagons, because we don't know it, we know that the number of sides is 722. So when I substitute, what I have to do is isolate the variable by using my algebra sense. And 720 divided by 6 is 120. So therefore, 120 octagons would have 722 sides. In your next question, question 5 says, make a table of values to show the number of circles in relation to the figure number. So again, it says the number of circles to figure numbers. So if I'm thinking about is there anything that gives me 1, 2, 3? Because not always, it doesn't always give you 1, 2, 3, but typically in these easier ones it does. So if I think about figure number, figure 1, so we're going to call this one F. I have that backwards. So what we want that to be is F for my figure number, and over here we're going to have C for number of circles. Okay, so in figure 1 there are 5 circles. In figure 2 there are 8 circles. And in figure 3 there are 11 circles. Develop an equation. So we're going to find their differences in the y column, which is adding 3. The differences in the x column, which is adding 1. 3 divided by 1 is 3. So therefore, in my relationship between F and the letter C, the coefficient for F is 3. Take any ordered pair. I'm going to take the first one because it's easy, so 1 and 5. 3 doesn't equal 5, but again, just like the last one, if I add 2, I have my equation. So now that I have my equation, I can answer question D and E. So write your equation of 3F plus 2 equals C. I'll do it twice, just for D and for E. So substitute figure 17 to figure out how many circles there are. So figure number 17 will give me 51 plus 2 is 53. So therefore, this one, 53 circles. And for the next one, which figure number has 110 circles? So I know my circles for this one, so I'm going to put 110 here. Isolate using opposite operation. 108 divided by 3. 108 divided by 3 is 36. Therefore, what figure number? The 36th figure would have 110 circles. In my next question, I have make a table of values for this. So just like the last one, my 1, 2, and 3 is going to be my figure number. So figure number. My F is going to be my X column. And my S is going to be number of squares. So figure 1, 2, and 3. Okay. Now what I'm going to do here is I'm going to do it a little bit differently because I'm going to show you how it would be presented maybe in a test. Make a table of values for the green squares to figure number. So the first one has 8 squares. The next one has 12 squares, and the third one has 10 plus 6 is 16 squares. Okay. So if I look at my difference here, I'm going to end up with an equation of 4 multiplied by the figure number plus 4 equals y, right? That will be my equation. And for D and E, I'm going to take my highlighter this time. For D and E, D says how many green tiles are in figure 24. So sometimes on a test, you'll have your teacher write 24 in the F and a blank for the S. And which figure number has 176 green tiles? And have 176 for the squares and nothing for the figure number, so you'd solve it. So here we would simply take our 24, substitute it into our equation, and get 96 plus 4, which is 100. And then all you'd have to do is take your 100 for your y value or your s value and put it there. And for your y value of 176, take your equation and put 176 there, isolate it, and f will equal, if I can bring my calculator, 172 divided by 4, which is 43. So therefore you'd say 43 is the figure number, and the number of squares in figure 43 is 176. Question 7, this time it doesn't give us a picture, but it gives us the following number pattern of 7, 16, and 25. Make a table of values for the first 5 terms. So it calls it terms. So what we're going to do here is, remember, I want to see, is there anything I can make 1, 2, 3? And there is, because T is the term number, and V would be its value. All right. So the first term is the value of 7. The second term has a value of 16, and the third term has a value of 25. So if I think about the terms in the pattern and its value, I could make a table of values like this. It goes up by 9 each time, and it goes up by 1. So at 9t equals v. So my equation, once I substitute, will be 9t minus 2 equals v. Once we have that, for the 123rd term, what is its value? And for what term has a value of 358? I can extend that into my table of values. Take t as 123 and substitute it. Multiply 123 by 9 to get 1007. Take away 2 from that, and you get, 1107. Take away 2 is 1105 equals the value. So here, 1105 would be your value of the 123rd term in your pattern. Taking that same equation, this time I'm going to substitute a value of 358. Isolate. And t will equal 40. So the 40th term will have a value of 358. Question 8 says the figure shows 2 regular heptagons. Draw the first 6 figures. Well, we said we didn't have to do that. Okay, we can kind of skip that. Actually, you know what? We're going to skip the whole question. We'll go on to question 9 because it's too hard for me to do and too long. So skip 8, go on to 9. Jessica created a number pattern that starts with the term -5. So I'm going to put -5 and a comma. Each subsequent number is 3 less than the previous number. So 3 less than -5 would be -8, and then -11, and then I'm going to put a dot, dot, dot. Make a table for the first 5 numbers in the pattern. Well, actually, I can't go dot, 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 can I? I have to go the first 5 numbers. So I'll go -11, -14, and -17. Those are the first 5 numbers in the pattern. So in my table, I'm going to put, hang on one second. Just like the last one, T for term, and V for value. So the first term is -5, the second term is -8, the third term is -11, the fourth term is -14, and finally the fifth term is -17. What equation can be used for this? We're going to do our pattern recognition. We're going to go down by 3 and up by 1. So -3 divided by a +1 is a -3. So in my coefficient, I'm going to have a -3 coefficient. Substitute the pair. And the constant needed is to subtract 2. So therefore, there is the equation to balance the 2 sides. And once you have that equation, question C and question D are going to be very easy. So what's the 49th term? Substitute 49 for your term to calculate its value. -3 times 49 is -147. And -147 minus 2 is -149. Therefore, the 49th term is -149. And if I take my equation one last time, what term has a value of -119? So this time I know the value. Isolate. And divide both sides by 3. 39. So a negative divided by a negative is a positive. So therefore, your answer is positive 39 because you would divide both sides by -3. Question 10. What equation? So you're given them, find the equation. So here, my difference is 3, my difference is 1. So for this one, it's 3x plus 13 equals y. For this one, the difference is 7. The difference is 1. So it's 7r plus 17 equals y. For here, oh, this one's a little bit tricky. Goes up by 2.7, up by 2.7, goes up by 1. So 2.7k, substitute my 1 in here, to equal negative 1.3. 2.7 does not equal negative 1.3, but if I subtract 4, I will get my t value. So the equation for that is 2.7k minus 4 equals t. And finally, going down by 3.5 and up by 1, negative 3.5f. Substitute 1 there. Since negative 3.5 does not equal negative a half, if I add 3, I end up with, oh, not my y value, but my w value. That should be w. Question 11 says, Rob is in charge of arranging hexagonal tables at a parent night presentation. Tables which can seat 6 people can be connected to form longer tables. Develop an equation to model the equation. So I'm going to put p here instead of my x for a number of tables, because I want it to be the 1, 2, 3. And this is going to be s for seats, number of seats. Or I could have used p for people or n for number of people. It doesn't matter. So one table is 6 chairs. 2 tables is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people, because right here and here, there's no longer people sitting there, so it's 2 less. And for the next one, you would have 14 people if you counted the chairs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Work out the equation. You're going to get 4 multiplied by t plus 2 equals s. How many parents can be seated at a row of 5 tables? You would substitute 5 for your number of tables, and the answer would be 22. And a group of 30 people wants to sit together. How many tables? You put your 30 right there. 4t equals 28. T equals 6. No, sorry, 7. 7. 7. Question 12 says a school pays a company $125 to design gym t-shirts. It costs an additional $15 to make each t-shirt. Copy and complete the table of values. So 0 t-shirts is still going to cost you $125 for design costs. If you order 5 t-shirts, it will cost you the $125 plus 5 multiplied by the $15, which will equal 125 plus 75, which is $200. If you ordered 10 shirts, you would substitute here for 10. It would be 125 plus $150, which is 275. And as we can see for our pattern, it's going up 75, up 75, up 75 to 350, up 75 to 420. Oh, no, that doesn't work there. Oopsie daisy, because we go up to 35. So if I complete it just like this, I have part of my equation done. But what we want to do is we want to look, I stop here because as you can see, it goes up by 5, up by 5, up by 5, and then it goes up by 20. So I don't want to include that last one, because I want to make sure that I just include the ones that are part of my pattern to work. So up 75 and up 5. 75 divided by 5 is 15, which means that is the coefficient that shows the number of shirts in relation to the cost. So $15 multiplied by the number of shirts you buy, plus that design fee of $125. This is the equation that I can use to figure out the cost. multiply your number of t-shirts by $15 a shirt, and then add $125 for your design fee. So it says, what would it cost to make 378 shirts? So 378 shirts right here would be this equation. Multiply 15 by 378, you get 1560 plus $125. So to make 378 shirts, the cost would be $5,795. It says the school has a budget of $23.45. How many t-shirts can be ordered? Take your same equation, but the cost is going to be no more than 2,345. In actuality, we can go back to the last one. The cost has to be less than or equal to, really. So really what we have here is an inequality, not an equality, right? And if we isolate it, we get 15 times the number of t-shirts will be less than or equal to 2220. Divide both sides by 15. And the number of shirts can be less than or equal to 148. So therefore, what we really want to say there is the school can order up to 148 shirts. And that's it.